Hello, hi, my name is Akan. I'm currently doing a presentation of Open Nucleus for the Azera Hackathon. Peace Training Sheffield Children's Hospital and also an NHS Clinical AI Fellow. So essentially, I decided to build Open Nucleus, which is like a new way of thinking about electronic health records. My aim was to try to make something that was lightweight, that you could easily deploy in like a resource-constrained setting. More specifically, in like a sub-Saharan setting or like for military application or like in disaster places where you have like natural disaster zones. But in trying to do that, I created like the main server, which was built in Go. But then I discovered that I could actually solve multiple problems from this one library, and it led me down the track of like creating multiple libraries for this. And I created like a library called Open Sentinel that it's essentially like an AI sleeper agent that works on top of health data and open farm dosing, because I discovered there was absolutely no standard API where people building applications that needed things for certain pharmaceutical terms could easily tap into. And then Open Ngram, which is one that I'm incredibly proud of, is like like a memory store for LLMs that is 100% that is modeled from how the brain works essentially. And then Open Anchor, which essentially talks to Hedera blockchain. The slide talks about lots of people. I'm just going to jump straight into the demo. So there's a DApp that links to the GitHub itself, and the GitHub has all of the libraries there with all of the commits which can be verified. And the server is currently deployed on render, and it's live. It's got an endpoint that you can hit. But focusing on the server itself, which is like probably one of the most robust ones, you could see the release there, which is the Open Nucleus DApp itself, which is written in Tauri, but the backend is written in Go. So if you download the DMG and install it on your Mac OS, it brings you to this. And if you test the connection, this is actually connecting to the Go backend, which is deployed on render. If you're connected for the first time, it asks you to generate a key pair for your device, and I'm just going to log in with demo, because essentially log in with whichever practitioner ID you want, and then it takes you straight to the dashboard. All the data here is not actual patient data. It's like a simulated data, just as a proof of concept that you can actually that this is actually like a system that's usable. You can anchor from this main DApp into the Hedera blockchain. I implemented like a formulary, which is still like a work in progress. And on top of this, you can see some of the multiple services like the Anchor service and the Sentinel service, which are on standby. And if plugged into the main data store, are ready to like find do certain things. Take for example, to scour over this data and be like, oh yeah, there's been like an uptrend in the amount of people who are having cholera in this specific geographical location. That's what this Sentinel agent is designed to do. It actually works because it's connected to like an LLM, so it's a library that you can test on its own. You can also log out. I'm just going to log back in again. Oh yeah, so you always need to test before. It doesn't let you log in before you test. You can trigger a sync from this, and it anchors it to the blockchain, and then you can view each individual patient's records. You can view their vitals, you can view their conditions, their medications. And the most important thing about this is it uses a specific kind of sync service. It's designed to run on a very lightweight computer, like a 75-pound Raspberry Pi. And it has a special way of syncing, which it does via Bluetooth or via Wi-Fi. And the killer thing is it doesn't use a conventional sort of storage. Is built off Git, so it views patients' records as Git files, which is something I've never done before. It's just like a crazy idea that I had for this hackathon. I hope you spend time studying this. This is like probably one of the best projects I've built. Thanks for giving the opportunity to do this.